Yeah, we certainly know that aging is not one size fits all. People age differently. Some people age in a healthy way, and some people age in a not so healthy way. There are different trajectories of aging. So I think it's important to recognize that and better understand why some people age better than others. Cellular nutrition and aspects of mitochondria metabolism are just one part of that, but I think if we can better understand how mitochondria relate to energy production and why people age better than others, I think that'll solve a lot of the issues or questions around healthy aging versus unhealthy aging. So mitochondria are fundamentally important for generating energy in the cells, and not just muscle cells, but really most of the cells in the body. So mitochondria are very important for taking in fuel sources like carbohydrate and fat and really converting them to energy. Well, we really investigate the role of mitochondria in muscle health. Obviously, muscle is very important for how people move around and function on a daily basis, but it's also becoming more well known that mitochondria are also fundamentally important for brain health. Mitochondria are essentially important for brain health related to Alzheimer's disease, early dementia, and just overall a healthy brain. Well, it's fairly well known that mitochondria, along with other cellular components, are part of this cellular aging process. It's not so well known how we can really mitigate those effects of aging on mitochondria and other cellular components. So I think it's really important to better understand how we could prevent some of these age-related declines in mitochondria function, perhaps through better nutrition or lifestyle changes like exercise. It's really difficult to assess. Most of the time, people start having problems with just fatigue. We know that mitochondria dysfunction or malfunction is related to fatigue and other abnormalities in a metabolism that oftentimes you just can't measure. So that's why the research is really important to help us understand, what clinical manifestations are involved with, so-called mitochondria dysfunction. Well, certainly you have the case of classic mitochondria gene mutations, these mitochondria myopathies, mitomyopathies that we consider. These patients do present with general fatigue, weakness, but I think this is also relevant to the general population who experience maybe not overt mitochondria disease, but rather just subtle changes in their function, differences and changes in their mitochondria that could be intervened upon. Well, we know that exercise is a classic way to improve mitochondria function, but we also know that many of these older people have trouble exercising, they can't or simply do not want to exercise. So while I don't think we are going to be able to bottle exercise in a pill, I do think that we could come up with some ways to help promote the positive benefits of exercise through perhaps some nutritional interventions that would then support someone's ability to do more activity. Well, we know that diabetes, for example, puts older people at a greater risk for losing more muscle, further disability, et cetera. We also know that diabetes itself is related to mitochondria problems in skeletal muscle and perhaps other organs. So this is certainly a complication of aging. As people get older, there's a diabetes risk associated with aging. So I would say that diabetes is one, but I think on a more sort of acute basis, we know that Sometimes when these older people get hospitalized or they have injuries or illnesses, they have these acute phases of physical inactivity, and we know from some of the research that these acute phases of physical inactivity through injury and hospitalization and disuse are really bad for mitochondria. So I think interventions that we could implement that would help support mitochondria in those settings would be really valuable. I'm not aware of any specific interventions that would affect mitochondria function outside of exercise or physical activity. So again, I think this is an area that really needs further investigation to really highlight that need. Well, again, mitochondria are essential powerhouses of the cell, so anything that we could do to support the function of these mitochondria to make energy production more efficient, I think would be very beneficial. Yeah, there's quite a bit of data out there suggesting that lifestyle modification like exercise, increased physical activity are very powerful interventions, lifestyle changes to improve mitochondria. What's not really well understood is how dieting or weight loss might affect mitochondria. Through some of our work, we would strongly suggest that weight loss by itself, whether it's through dieting or even bariatric surgery, does not really promote positive changes in mitochondria, that you really need exercise or perhaps some other nutritional interventions to better your mitochondria. You know, that's a great question because to measure the mitochondria function is very difficult. Usually it's in a research setting. So I think we have to look at surrogates of what might relate to worsening mitochondria function like walking speed, fatigability, just physical function testing that we could come up with perhaps that would relate to mitochondria but would be some of the first signs that there's something going wrong with your mitochondria. Well, I would just say that, you know, we often think of energy metabolism, mitochondrial energy metabolism as simple as putting fats and carbohydrates in the body, and that's what we think of as cellular nutrition, but it's obviously a lot more complicated than that. You know, cellular nutrition, I think, involves more than just carbohydrate and fat metabolism, but rather involves other aspects of cellular nutrition to really support energy metabolism, and we're just now understanding what some of the mechanisms are that relate to these other aspects of cellular nutrition.